Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 4 by 6 of Engineering Mechanics Statics 9th edition. Statement of the problem is determine the forces in member BE. So there is BE and CE. So need to find forces in member CE and BE of the loaded truss. So the steps are here. Number one, select a joint with at least one known force and two or less than two unknowns. So there are only two known forces here. One is 5 kilonewton at B, but at point joint B, there are three member forces which are unknown. So we can't select that joint B. The next one, 3 kilonewton is acting at uh, joint C, and again joint C has three unknown forces, member forces, so we can't select a joint. And the next one is if no joint satisfy this condition, determine the support reaction first. So for this process, first we have to find support reaction. So steps to find support reactions are number one, draw free body diagram of the entire truss, ignoring internal members and replacing supports with reaction. So there are two supports here. A is a pin support. It has two reaction Rx and Ry. At point at joint D, there is a roller support and it has one reaction which is perpendicular to the surface. Free body diagram is drawn here. So support A that has two reactions, support D that has one reaction, and then assume convenient direction of all reactions. So any direction of reaction can be chosen. It doesn't make any difference by looking at the forces. So it doesn't make any difference that which one you are going to choose. But anyway, once you are going to solve for the reaction, so then a positive result confirm the assumed direction is correct, and negative results mean actual direction is opposite. So now we have all that. So the next step is to apply conditions of equilibrium. So we need to start with the conditions of equilibrium, sigma m equal to 0, and need to choose the moment point that has the most unknown. So point A has the most unknown. So then I'll select point A as point of rotation, or that is the moment point about which I have to take the moment. So now the 5 kilonewton load is being applied at B, 3 kilonewton load is being applied at C, and dy is being applied at D. So the line of action of dy and the perpendicular distance from the line of action of dy is given as 3 meter plus 3 meters, so total 6 meter. But the line of action of 5 kilonewton is going to act here. Okay, so we don't know that what is the distance from, let's say I am going to map that point as B dash here. Okay, and then I'm going to map that point here as C dash. So actually required is a distance from A to B dash and then distance from A to C dash. So these distances are required. So for to go further, what I can do, I can use similar triangles rule. So the similar triangle rule says that here ABD, so ABD is similar to ECD. That angle theta is the same. So when that angle theta is the same, so then the total length, if it is 6, so the ratio of uh, like AD to ED is equal to ratio of AB to EC. So using that ratio, so then EC is 1.5 meter. And then I can find out the distances here. And so now again using similar triangles, if angle BAD is 45, so CED must be 45. So now 3 meter is given. So if I draw a perpendicular line from B to B dash and C to C prime, So then it is possible for me to find the distance from A to B, and the distance from A to B, if angle is given, which is 45, so that is basically horizontal component of that AB. So let's say if there is a right triangle in which hypotenuse is given and angle alpha is given, so horizontal component of the distance is a displacement is A cos alpha, so it is going to go, this distance is 3 and then cosine 45. And similarly, the distance from E to C, this distance is, that distance is 1.5 cosine 45. So the distance from A to E is 3. So that is 3 distance. Okay. So now I can find moment due to 5 kilonewton. So that is a line of action of 5 kilonewton, and it is trying to rotate that AB in clockwise direction. And 3 kilonewton, that is a line of action of 3 kilonewton, and that 3 kilonewton is trying to rotate AC dash in clockwise direction. And then dy trying to rotate AD in anti-clockwise direction. So in the calculator, it can be used as, so because dy is unknown, so x times 6, so x is with alpha and x, minus 3 times 3 plus 1.5 cosine 45 minus 5 times 3 cosine 45 equal to 0. So you can put that equal sign using alpha like this way. Okay, and then shift, solve, and the value of x is 3.7981. So that is the value of x. So now dy comes as positive 3.798. So that is dy. So now I can use sigma fy equal to 0 to find ay. So for sigma fy, ay is acting upward, so positive, plus dy is acting upward, so positive. That 5 kilonewton act downward, so that is negative. So minus 3 is equal to 0. So ay is minus 8 and then minus 3.7981. So minus 3 minus 5, it will go minus 8. So when it go to the other side, it's plus 8 and then minus dy, which is already calculated. So then ay comes as 4.2019 kilonewton. So both of the values are positive. So it's mean that the direction which is assumed, that is appropriate or that is correct. And then if required, so then I can go for sigma fx equal to 0, because there is only one reaction in the horizontal direction. So ax is equal to 0. So now I can write the answers. So ay is 4.2019 kilonewton and it is in upward direction, and dy is 3.7981 kilonewton and again it is upward direction. So now reactions are calculated. Then I can again start from the step 1. So now at joint D, one is known reaction and there are two unknown member forces. So I can start with joint D, or otherwise I can start with joint A, because at joint A, ax is equal to 0. Okay, so here again one known and two unknown, so it is your choice, you can go for any joint. So I'm going to select here joint D and then isolate the joint, draw feasibility diagram, assume all unknown member forces act in tension. The joint D is isolated, So CD and DE both are assumed as in tension. Now resolve inclined member. So CD is an inclined member, so it will have two components. One is CDY and the other one is CDX. So that is CDX. But to find component CD, angle theta here, this angle theta is required. So then this angle theta, it can be calculated using geometry. And for geometry, you need to reanalyze all that truss using similar triangles and using all the rules of geometry. So now finding angle ADB, which is theta. So again, I'll use that here is 1.5. So angle is 45. So then EC dash is 1.5 cosine 45. And then CC dash, it will become 1.5 sine 45. And the total distance from E to D is 3 meter. So then in the triangle CDC dash, so this distance will be then 3 minus 1.5 cosine 45. Now in the triangle CC dash D, I know opposite and then I know adjacent. So then here I can use tan theta, which is opposite C dash over adjacent C dash D. And CC dash is 1.5 sine 45 and C dash D is 3 minus 1.5 cos 45. And then theta is equal to tan inverse of all, which is equal to 28.675. So angle theta is calculated as 28.675. So now I can use this joint D to find unknown values. Now I'm going to apply sigma fx or sigma fy equal to 0. Now in vertical direction, so there is only one unknown component. So then I'll go for first sigma fy is equal to 0. And for sigma fy equal to 0, I have CDY as positive, and then reaction is also going upward, so that is 3.7981 is equal to 0. So CDY is because angle is with the horizontal, so y component will be sine, so that is sine 28.675 is equal to 3 minus 3.7981. So then CD can be computed as minus 7.9153 kilonewton. So then I can apply sigma Fy equal to 0. So sigma Fy equal to 0. So what we have here for sigma Fy, so the DE is towards negative y axis. So then DE is negative minus CDX is equal to 0. So DE is CD minus CDX, which is equal to minus 7.9153 into sine, because cosine, that is 28.675. So then DE is plus 6.9446 kilonewton. So now I go and see what are the rules for interpretation of sines. So here interpretation of the sine is positive value indicate tension and a negative value indicate compression. So now CD is negative. So CD is now 7.9153 kilonewton in compression, and then DE is 6.9446 kilonewton as tension. So now CD is in compression, so I can show that compression mean that direction is towards the joint, and then ED is DE is in tension, so away from the joint. So now these two members forces are known now. Now repeat step 1 to step 3 for adjacent joint that now have less than or equal to 2 unknown. Joint C, there are 3 member forces, 1 known, 2 unknown, so I can go joint C. Otherwise, I can check joint E, but at joint E, there are 4 member forces, and for those 4 member forces, 3 are unknown, so then I'll go for joint C. And I'm going to isolate that joint C to solve. So joint C is now isolated. Free body diagram has been drawn. So BC and CE, they are assumed in tension, and now need to find the angles because both BC and CE are inclined member, and that CD, which is already calculated, so CD, which is already calculated, that is in compression. So now using geometry, if I draw a horizontal line passing through C, so then angle, this one angle is theta, and then this angle will also be theta. Because that angle is 45, so using the similar triangle, angle CED is also 45, and then when I'm going to draw a horizontal line here, so angle here, that is also 45. So the next step is we need to resolve these inclined members into their components and then need to apply conditions of equilibrium. Now joint C, it has B, C, CE and CD as inclined components. So CD is resolved into its component CDX, which is towards the left, CDY, which is upwards. Then BC, it has one component going upward, BCY, another component BCX is going towards the left. And then CE, that has again two components, CEY, that is going towards negative y-axis, and then CEX towards the left or negative x-axis. So now here, because there are two members unknown in horizontal direction and two member in vertical direction, so then I can go either sigma fx equal to 0 first or sigma fy equal to 0 first. So starting from CDX, so that is minus CDX, and then minus BCX, and that minus CEX is equal to 0. Now BCX, now all these components I can find. So BCX is minus BC cosine 28.675 because BC makes an angle theta, and then BCD is 7.9153 times cosine 28.675 because that angle is with the horizontal, and then CE makes an angle 45, so that is minus CE cosine 45 is equal to 0. So then this can be rearranged further. So it is BC cosine 28.675 minus CE cosine 45, and then all that term will go on to the other side, that become positive. So now I can apply sigma Fy equal to 0, and applying sigma Fy equal to 0, the first one, 3 kilonewton load is going to act downward, minus 3, and then BCY is upward, so that is BCY, and then CEY is going to act in downward direction, so that is negative, and CDY is going to act in upward direction. So then these all components can be computed from there. So now BCY is BC sine 28.675, CEY is CE sine 45, and then CDY is 7.9153 into sine 28.675. So now I can rewrite it as BC sine minus CE cosine, and minus 3 minus all that term when it's being added and go to the other side, it will become minus 0.7981. So now these are two simultaneous equations. So I have to solve these two simultaneously. So I'm going to solve these two simultaneous equation using Casio FX991EX. So please go to menu and then third row, and then second column is for equation alpha A. So now I'm going for simultaneous equation number 1, and number of unknowns are 2. So then I need to input all the values there. So the calculator is going to assume BC as X and CE as Y. So the coefficient of BC, which is X, is minus cosine 28.675. So just input minus cosine 28.675 and press equal. The other one is that is minus cosine 45. So that is minus cosine 45. Press equal. And then on the other side it is positive 6.9445. So after inputting all the values there, so like minus minus and then the values, so if you press equal, so that is X. X is actually BC, which is 5.7048, and then Y is CE, which is minus 2.7426. So BC is minus 5.0748 and CE is minus 2.7426. So now interpretation of the answers, because both answers negative value indicate compression, so then both of these answers are in compression. So BC is 5.7048 kilonewton as compression, and then CE as 2.7426 kilonewton as compression. So these are two values. So now we can write there BC and CE. So both are in compression. So BC is in compression, and then CE is also in compression. So the next one we can go for further. Either we can go for joint B, because at joint B there are three reaction forces. So member forces, sorry. So one is known and two are unknown, and the other one I can go at joint E, because at joint E there are four member forces. So two now are known and two are unknown. So next joint selected is E, and for E, CE and DE are known, and BE and AE, they are assumed in tension. Now the angle CED using similar triangle is 45 degree, but angle BEA is unknown, which is phi. So need to find that angle BEA first, so we can resolve that BE into its components. So here again I'm going to use to find that angle phi now. So now the angle, this angle BE, which is phi, so it is required. So now that is 3. So this distance will become simply 3 cosine 45. That is 3 cosine 45, and this vertical distance, it will be 3 sine 45. And then BE dash distance, because AE is 3 meters, so this distance is then 3 minus 3 cosine 45. So then again I can use here tan phi is equal to B dash over B dash E. or phi is equal to tan inverse B dash over B prime or B dash E. So after substituting value of B dash as 3 sine 45 and B dash E as 3 minus 3 cosine 45, so the angle phi is 67.5 degrees. So now that 67.5 degree angle is known, so phi is known. So uh, I, I can write that as phi here, and that phi is equal to 67.5 degrees now known. So now I can further analyze this joint. So at joint E, we need to simply find BE. AE is not required because we have already calculated CE. So now we have found that BE. So for that purpose, we need to resolve them into their components. Okay, so DE is already horizontal. So then CE is in tension. So it's one component CEY is negative, and the other one is here, which is CEX, that is again negative. AE is already negative. So for BE, if one component is BEY and the other component it will be BEX. So now I have only one unknown in vertical direction. So I'll apply here sigma Fy equal to 0. So while applying sigma Fy equal to 0, so BE is plus BE because that is upward positive, and then minus CEY. Okay, and these are the only two components is equal to 0. Now BE, that makes an angle 67.5, an angle is with the horizontal, so its vertical component will become sine. So BE sine 67.5 minus, and CE will go on to the other side. So CE, we already know it is, so CE is 2.74, that is 2.7425, and it is making an angle theta 45 with the horizontal. So then it will have vertical component as sine 45. So then BE can be calculated as, so BE is plus 2.099. So there is no need to find AE because it's not required. So then the final answer is BE as 2.099 kilonewton in tension. So now BE is 2.09 kilonewton in tension, and that is 2.10 kilonewton in tension. So if you round off that 2.099, the other one is CE 2.74 kilonewton in compression, and CE here is 2.7426 kilonewton in compression. So that is all about problem 4.6. Thank you very much for watching.